let's do question 6c. Consider the letters of the word square. The word square is composed of how many letters? Let's see. 1, 2, 3, 4, 5, 6 letters. Right. If the letters are arranged in any order without repetition, to form different words, determine the probability that the word formed will start with an S and end with an E. Okay, how do we do this? So we have to apply the counting principle to solve this probability problem. We have to apply the counting principle to solve this probability problem. Okay, let's just discuss a bit before we come back to our question. Right, what does the fundamental counting principle state? It says that if there are A ways in which one activity can occur and B ways in which a second activity can occur, then there are A times B ways for both to occur. Remember, this can be extended to more activities. It's not about two activities only. Right, let me use this example to try and explain what I mean by this. Let's say you are going to buy pizza, right? And then how do you choose your pizza? How many choices do you have? Right, we choose our pizza depending on the size. Okay, it can be size, it can be what? Small, maybe. It depends on the Pizza Hut that you're using. Right, let's say this particular one is small, medium, and large. Right, and then also we choose according to the base. So the size is one activity, or let's say one event, okay? And then base, it can be thick or thin. See that? So here there are three outcomes, here there are two outcomes. And then let's say this particular Pizza Hut, they have 4 flavors. So also we choose according to the flavor. It can be pepperoni, or it can be barbecue. There are different flavors. Maybe let's say chicken mayo. And then let's say maybe vegetables. Let me just say veggie. Okay, so here there are 4 of them. So now let's go back to the thing. It says the fundamental counting principle states that if there are A ways in which one activity can occur and B ways in which a second activity can occur, then there are A times B ways for both to occur. But now we have 3 activities here. Okay, now so it means we have the size, we have the base, we have the flavor. Remember, we can also do this using the tree diagram and see all the possible outcomes, okay? But it's going to be too much if you're using the tree diagram. So it's better to use the counting principle, right? So the size, how many different ways do we have? We have 3. And then the base, how many different ways do we have? We have 2. And then the flavor, how many different ways do we have? We have 4. And then we're saying that then there are A times B ways for both to occur. So it means now we have 3 times 2 times 4 ways for all the 3 to occur. You see that the different choices that we have here, there will be 3 times 2 times 4, which is equals to 3 times 2 is 6, 6 times 4 is 24. So it means if you are going to this Pizza Hut to choose pizza, you have 24 choices. And you're going to choose. If you're choosing 1, it means it's 1 out of 24. You see that? Okay, right. Now, that's what it means here when I talk about the counting principle. Let's use the the letters of a word, for example. Let's say the question will say, how many possible ways can letters in the word run be arranged if the letters are repeated? We're going to start with the A, which says repeated, and then B, not repeated. Right, to explain this, I'm going to use the positions of the letters. I'm going to use what? The positions of the letters. We're going to have position 1, position 2, position 3, because this letter is composed of 3 letters. Okay? And then A, it says that the letters can be repeated. So, position 1. How many choices do we have for position 1? The letters can be repeated. So it means we have 3 choices. The first letter can be R, can be U, can be N. So we have 3 choices here. You see that? And then what about position 2? How many choices do we have here for the letters? Again, we have three choices because the letters can be repeated. Can be R, can be U, can be N. So we have 3 choices. And then what about the third position? The letters can be repeated. We have 3 choices again. It can be R, can be U, can be N. So we have 3 choices. You see that? So how many possible ways now can these letters be arranged? It's going to be 3 times 3 times 3, which is what? Which is equals to 27. You see that? Okay, that's the first one. And then B, the letters should not be repeated. So position 1, let me write the positions here. Position 1, you have got how many letters to choose from? How many letters to choose from? We can choose from 3 letters. It can be R, can be U, can be N. But now, if we have the letter in the first position, 1 letter in the first position, so it means in the second position, we have to choose from 2 letters because the letters cannot be repeated. Let's say, for example, let's say our first letter was N. So it means the second position can be occupied by R or U. If the first letter is N, then the second position can be occupied by R or U. So we have 2 letters here, which can occupy position 2. Right. If position 1 is occupied, position 2 is occupied, we are left with only 1 letter for position 3. Let's say the first letter is R, the second letter is N. Then the third letter is just 1 letter to choose from. So we have 1 here. So now how many different ways can these letters be arranged? We have 3 times 2 times 1, which is equals to 6. And then this one is a special way. We write it in a special way, right? 3 times 2 times 1. We say this is 3 factorial. 3 factorial. Remember that, okay? I'm just reminding you, okay? And then the last part before we go back to our question. How do we find probabilities using what? The counting principle. Right, the probability of an event A occurring, we're saying it is the number of ways the event can occur divided by all of equally likely possible outcomes. Remember this. If it means writing it down, write it down before we go to our question. Probability of event A happening is the number of ways the event can occur divided by all of equally likely possible outcomes. Right, let's go back to our question. Consider the letters of the word square if the letters are arranged in any order without repetition to form different words. Determine the probability that the word formed will start with an S and end with an E. Right, so now it means what? These 2 letters are fixed. We don't make any choice for this, for the first letter and the last letter. So the letters that are going to be arranged in different ways are these 4 letters. Now it says without repetition. If I may ask, how many possible ways can these 4 letters be arranged? We just talked about this. There are 4 letters here without repetition. How many possible ways can these 4 letters be arranged? Is 4 factorial, because it's going to be 4 times 3 times 2 times 1. So it's 4 factorial. Let's call this event A. Let's call it A. So probability of event A happening, and then what is N? Probability of the number of ways the event can occur over NS here, the sample space, which is all of equally likely possible outcomes. So now, our probability of event A here is going to be 4 factorial divided by what? All of equally likely possible outcomes, which is coming from all the 6 letters here. The 6 letters. So it's going to be from 6 factorial divided by 6 factorial. So it's going to be probability of A is equals to 4 factorial divided by 6 factorial. And you can use your calculator to find this. Okay, you know how to use your calculator. But if you can check, this is just same as 4 factorial divided by 6 times 5 times 4 factorial. You see that? Because from 6 times 5, we're going to have 4 times 3 times 2 times 1, which is 4 factorial. And then 4 factorial divided by 4 factorial is 1. So probability of A here is going to be 1 over 30. Done. Okay. Right, we're going to meet when we do question 7.